Right, so it's the LCL Communicator NI440DX late version with the clear meter, the second set from the same customer. So this is a hand-painted thing, it rattles and it's got a missing TX light. So, it's also got some wrong screws which look like they've come out of a video recorder, to be honest. Oh, are they push-in screws? Yep, they're push-in screws. Might be able to do something about that. I'll take it in the organ workshop and bash the chassis with a hammer and then re-thread it. But we'll wait to see whether we can get the set to work first. Yes, that's certainly the wrong kind of screw. There's a self-tapper. That was correct, and that one's missing. Alright, we'll put the soldering iron on, ready, and whilst that warms up, just connect the test equipment. Oh, right. I can't. Why isn't it on soldering? Oh, because it's not soldered on, it's wrapped around. Puts the right glasses on. So somebody didn't get a soldering iron for Christmas. My cutters are on the other bench. Right, and it's just wrapped round the back of the connector there, the one that is wrapped round. Oh dear, what's happened here? I think we better take the bottom lid off this one because I can see we're running into difficulties already. I could do with seeing why there's no TX light. It's just totally missing. Well, we've got spare red bulbs in stock, as they're not LEDs, they're our light bulbs. Right. So this one's got the proper bulb in, The RX light doesn't work, so that's something else we'll need to look at. It should light up green, and that will hopefully improve the sellotaped wiring. So Roger Bleep, off that to CB. Wants cleaning. Let's see what happens. So I'll switch the picture-in-picture on, which is more than I did last time. And we're going to show the transmitted power. So it's doing 2.5 watts. See whether it's on frequency. So we should be having 27.79125. Oh, it's 7. It's out of tolerance, out of frequency. It's 78995. See whether we can bring it up or whether it needs a crystal changing. Well, I'll tell you what, it's done it, hasn't it? I like to have it slightly high, so we'll... That'll do me. 79127, that surprised me. I didn't think it was going to do that. So I'll tell you what, we'll get a piece of paper. You can usually find a second-hand piece of paper. Oh, that was a picture of our new building before we started putting any tat in it. So we'll put it on here, NI440DX poor. Right, so TX equals 2.5 watts, frequency is 27.78995. That's now 27.79127. So that's cured that. Now we'll see where the deviation is. Whoa! Wallow, 4.5 kilohertz. Well out. Nothing like transmitting on 3 channels at once. You know what they do? They fiddle with them. They've got a mate at the other end. Does that sound alright? Yeah, that sounds alright. Oh, yeah. The mate's on a Fidelity 1000 and it can hear, you know. Whereas if it's something which was really sharp, with a bit of better filtering, you'd say, no, you're chopping at that point. You just get a deviation meter and learn about the subject, which is why we do these videos. So, I was going to say it all makes work for me, but I'm not looking for work. So here we go. Let's look at transmit. I'll just make sure the power supply is somewhere where it should be. So we're actually 2.4 watts. I'll tell you what, let's start with the VCO, because we found out a way of doing the VCO, didn't we, on the last video, if you watched the last NI440DX. So we may as well implement that on this one. So it was resistor 2. Resistor 2's down here somewhere. So we're going to put it on channel 40. Monitor resistor 2. It's 3.2 volts. We'll go to channel 1. 2.4. Now you can see it's been fiddled with. And let's see whether we can bring that nearer 4.
do me. Channel 1, 2.99. Right, now transmit. Channel 40, 3.6. Let's just get back on there. Just the yellow trimmer. Bit nearer 4. Channel 1, 2.85. So as far as I'm concerned, the VCO is right. The fact the wax in the coil had been disturbed told me it had been fiddled with, and this clearly has been a play toy set. This capacitor needs changing. It's starting the it's receding. The heat shrink tubing's receding on that. So next thing is that's going to go pop. So it's probably been overvolted. 15. If you go much beyond 15 volts, you're going to have this happen. Right, start then. So transmit. Why won't the tool fit in anything? How bizarre is this? Have all these cores been changed or something? Because the correct trimming tool doesn't fit. It's absolutely bonkers. Let's see whether the metal one fits. It's like they've all been super glued or something. I don't get what's happened here. None of the trimming tools fit in the... Well, do these... They've all been filled with super glue. Right. Well, we'll see whether we can get something above 3 watts with the ones we can get into. Because what I don't want to do is to have to unsolder every transformer in this. I don't know what we're going to do when we get to the receiver though. So that one's missing. That one's broken. So we're going to have to unsolder that to get that one out. Right, what I'm going to do, I'll just turn that round the other way. Yeah, it smells of cyanacrylite. I may have to try putting this in an ultrasonic cleaner. I just can't get that as low as I want it. Okay, a lot of bother. Right, I'll switch the power off. We'll have to get this coil out with its broken core. Well, I've never come across a radio where the coils have been super glued. And then I've got to hope to find a scrap chassis that we can nick some coils off. I'll pause the video while we get that out. Okay, well I managed to dig out a scrap chassis here, and it's also a late version with the clear meter. So I've managed to take the coil out from there, because despite leaving it in the ultrasonic cleaner bath, I did it for 15 minutes again rather than the 3 minutes, and then I left it in the ultrasonic cleaner static, shall we say, with the machine off whilst I went to church, and I've come back 90 minutes later and it still won't budge. So we may be able to recover the core out of it if I break away the coil. So we've got that one in. Let's see whether we've got transmit. We've actually got 3 watts now. So we'll see if we can peak these. I'm going to have to change scales because we're now going beyond the 3 watts, the radio. Sorry, the scale I was on. I don't know where this wants to be. There's two peaks. That's the second one. Okay, so let's see what we can do with that. Well, tell you what, we'll pinch the other coil. We'll pinch the other core out of the scrap set. Yeah, well, it needs to be right at the top. I'll just move that to its other point. No. see if we can put that in the other way around, because we tried that before. It's actually broken the ceramic tool. That's frustrating. Right. Well, I think we'll take the other one out of this and see whether we fare better. Okay, so we've just got to changing those and changing the coils. We've got to just over 3 watts. So we'll now set the meter to read 4, like you do. Oh, don't tell me these have been super glued as well. Okay, so that's not going anywhere. Wallow. So let's look at deviation. Wall. It would be alright if they super glued these in the correct position. Okay, well, that's broken in trying, you know, so I can see this is going to be a bit of a waste of time. So I'll unsolder that one. I can't even get vertical presets. So we're going to have to pinch one off the scrap set, which is not something which is very professional. I just can't believe anybody would be so stupid as to do this. So I've freed it off, but it broke the preset, so there you go. Right, we'll try that. One or two, 1, 2. Okay, so having done that, testing 1, 2, wallow.
That looks like we are spot on with the deviation. Are we on picture in picture? We are, but for some reason I've got no input. See if we can rectify that. Okay, looks like we're there. 1, 2, testing 1, 2, wallow. So we've got the deviation back where we want it. So that's replaced the preset off a scrap chassis. So I think we've got transmit where we want it. Yep. Be nice if we did more than 3 watts, but that's at 13.6 volts at the moment. We'll just put the power supply up to 14.4, which is the charge voltage of my own car. We'll just see what the power is doing there. It's about 3.1. It's a bit like a modern radio, which should come out of the box mostly doing about 2.7, and you can't get much more than 3.2 out of them. So I think we're there. We've covered the transmit. I'm not looking forward to the receive side of things. So let's see where the receive is, because to be honest, it doesn't seem that far out. It might be a situation where I'm going to just have to say, well, it's been set up okay, it's been sealed, and we can't be changing every one of these. Not only would you have a big bill, we've got to have, you know, the scrap sets to cover it. I mean, every time I'm using a second-hand transformer, obviously there's a fee, because they're irreplaceable, except from a scrap chassis. So why does it keep disappearing off? Could be down to that. We'll look at that wiring later. We'll change that capacitor as well. Oh, it's the volume control. It's dirty. Right. So moving on to the receiver. Not sure whether I can adjust anything on here. The fact that it's receiving at 0.3 microvolts. Let's just look where it is on the synod meter. We'll switch across to that. It's actually doing 0.56 microvolts for 12 decibel synod, so it's, you know, it is receiving okay. I'd like to check the detector. So let's go over to the oscilloscope and we'll see whether we can adjust that detector. So just remind myself, I think the detector's up there. It is. Yeah, can. Well, that's great, because at least we've been able to set that, and that's so important. I don't know if there's anything else we can check, so we'll go back to the synod meter. We must have forgotten to seal that under all that wiring. Oh, while we've got S9 on the screen, I'll tell you what we'll do. We'll just check that the meter's reading S9, because it's not, it's reading plus 40. So which is the S meter? You know, I've got two options, haven't I, with this? I can either say, I'm sorry mate, it's scrap. Or we can change everything and run up a ridiculous bill, and there'd be another set cheaper on eBay. Alternatively, we do what we can and keep that cost down. So Squelch is that one, and the S meter is this one here. So let's see whether we can adjust that one.
And the answer is it's another one that's been sealed. So it's reading a bit generous. It's not reading anything now, I've taken the power off it. So as you can see, at S9, it's just reading. I've managed to move it a little bit. It's reading about 10, so it's a bit generous. But I am just a bit scared of it breaking. We used to have this back in the telly days in the 70s, where you'd get mainly elderly people, and they'd mess with the alignment of television sets, especially colour televisions, when you need to be setting it up on an oscilloscope. And you'd have to spend hours resetting it. No, I can't do it. No. Let's see where the squelch is. So let's put the squelch to full. I want this to open up at S9, and it's opening up at 30 microvolts rather than the 100 microvolts I'd like. Now I'll just again see whether we can adjust that. Let's hope they've missed this one. They have. There we are. Been able to set that. It's right under that wiring harness. They've missed it. Not glued it up. Well, the S meter being a bit fast isn't the end of the world at all. Well, pleased with myself on that one. Right, we'll go back to the cyanide meter, on the cyanide meter, and just see if we can move any of these others. Because I can't believe that anybody who would do this would have the proper test equipment to set it up in the first place, even though it seems to be okay. We'll do it on the air test anyway, whatever the outcome, and we'll soon see what we think. So all this lineup is receive. We're not going to move that. That's a super glue to super glue comes. We're not going to move that. 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 No, so every one of those is sealed with super glue. The fact is, it is receiving okay. I'd like to. That's 0.3 of a microvolt. Right, let's go out to picture in picture. There we go. Let's see if we can tidy up this wiring where the this is all messed about around the speaker. Now, what they've done is to just twazzle it round without soldering it. So just see if we can put some of this right, some of this wiring. So it's, you know, I've tried my best, but it's a bit of a. You can all see that the only way out of this is to use a complete set of coils from a scrap set, which would be time-consuming and expensive. I mean, these sets are scrap, but they have to be paid for, don't they? You know, they don't They certainly don't come free. So hopefully we can just see what they've done with the wiring here. The brown wire goes to there. That needs soldering on to there. Yeah, it looks okay. It's just a matter of where does the speaker actually go. Well, we've got this scrap set here, and we know that one of the wires goes to that earth point, so that's going to be one of the speaker wires. Rather than open up his other set, I'll just see whether we've got a repair which is in with the lids off, half off or fully off. So I'll deal with that. Okay, just moving forwards with this capacitor 470, it's reading 583, and it's obviously been very hot. It's peeling back its sleeving there, so we're going to replace that anyway. I tend to find when they're high like that, they are on their way. So we'll just put another one in, 470 at 16. I will put a higher temperature in because we have those available. In fact, I think we'll put 470 at 25 in. Which helps if I pick the right one out of the box. I'm going to be very generous with this customer because, to be honest, I don't think this set was worth repairing, so it's really going to be a little more than a token payment. So, negative is indicated by the dot, which is the opposite to what I'm used to. I'll pop that in. So what I've done behind the scenes is I found we'd got a lens for the RX light. I think it was the RX one which was missing. So I've done that. So we've now got the TX and RX lights in. They're made to look like LEDs. This is at a time when LEDs would have been the latest thing. And in actual fact they are light bulbs. They're just the normal meter lamps which are now wired in. So you've got a lens held in by a grommet, and then the lamps are glued into that kind of assembly, which is what I've done with the hot glue gun. So they're all working. So the set's ready to put together. If you remember, I put the wiring on for the speaker, and just need to chop that off. I'm just going to put a dab of hot glue just on that coil. It's towards the end. I don't want it to move. We don't have Japanese wax to put in there, so mind you, the times when I have to run that out of VCOs, nevertheless, I'll just put a dab of hot glue on that just to stop it shifting in transit, and we should put it back together and we'll see whether anybody's on the air. So I'm disappointed that it has been super glued, but it's doing better than spec as far as receive goes. Transmits a disappointing 3.2 watts, which these can well be, but these are 3.2 of my Marconi test instrument watts. What I will just do is show you what it reads on a Zetagi meter, which is probably more which CBs are going to be looking at. So we'll just pause the video and I'll put it back together and put some glue on there. Okay, so I've got the case back on. I managed to get 7 out of 8 screws in. If you remember, they've had totally wrong screws out, and they've been, I think, drilled out, all kinds of things. But what I've done, it's a bit of a bodge, but I've actually glued some nuts on the inside of the chassis, and I've carefully screwed the speaker lid on with the back 2 screws into those, shall we say, captive nuts. But they wouldn't be that captive, would they? Because if you over tighten them, it's going to break the glue. So that's all I can think of doing. Had there been more room, we could have inserted inserts. So inserted inserts, yes, so that it would have something to go into. So it's a bodge all the way around, isn't it? But it might work. we'll just take just make sure it's transmitting. Voila, it is. Plug the aerial in. And let's see whether on a Friday at 1:30 there's anybody as I flick round. Bearing in mind, I'm in the middle of nowhere. So we've now got an RX light. 19er Roger. And we've got a TX light as well. Right, we'll do an on-the-air test with that, with Mr Chippie, and that will be back-to-back with the other radio which we did for the same customer. So we'll start off by going out with the good Communicator NI440DX, then we'll have Mr C come back to the petrol station, which is about 3/4 mile from us, and he'll start the test again, and we'll be able to compare. This is doing slightly less power. The other one was doing 3.2, I think it's doing about 3.1. One thing I did want to show you before we leave this is I will just put it on the Zetagi meter. So I've got a dummy load in this. And let's see whether we can get 4 watts on this meter. And the answer is yes, it's doing 4 watts on there. Right, we'll set it up for an on-the-air test, and thank you for watching the NI440DX that quite frankly should have been scrapped. Cheers.